All right, guys, we are going to start a new chapter of information in our notebook. So we want to go all the way to the end here. The last thing that we did was this tax stuff on page 13. But we're actually going to not put anything on the page behind it. So this is page 13, nothing here. On the next page, we're going to need to grab our packet of stuff that we got from textbook pickup. Hopefully you still have it. If not, I will put a link to print these notes off if you're able to print. But we want the one that on the front says solving equations. Yes. Okay. This is going to be our little tab divider to keep things organized. And what we want to do is we want to kind of fold this in a third. So I flip it over and then I fold that along this line here. And then this kind of goes around the very next page in our notebook. So this page right here, I'm going to push or put this around it so that the shorter side is on top and the longer side is on the back of it. And I always like to leave the little tab hanging out so that it can work as a divider. And then we just want to glue or tape it in. I'll turn the page and put a little tape there. And we are going to add one page to our notes today, kind of. We're going to talk about solving. We're going to talk about solving in general, like what that means, but also we're going to do specifically solving one-step equations. We're going to do that on page, what page are we on? What page did I just say that was? 13, 14, 15, and 16. So 14 to 16. So we'll call this actually right next to this page 14. If you turn the page 15, and page 16 right here, and we'll get our notes set up, and then we're going to go back to page 14. We're not going to put any of the printed stuff on 14, but the next one that you should have is this one here. And that long rectangle that says leave blank, we can cut that off. And then if we want to turn it this way, we're going to fold in like that to get two little French doors. And then if you want to make it super cute, you can cut along the dash line to make 4 doors. And this is going to be taped towards the bottom of 16. Then the next one as well has a bunch of numbers all over it. That one we don't need to cut anything. We're just going to fold in to the center, get those French doors, and then cut out if you want to get 4 doors. Now this one we can glue or tape onto page 15. And then we're actually going to go back to page 14. So I got that all set up. So I want to talk with you about solving in general. And then we're going to break it down over the next couple of days, step by step, starting really small, working our way up to a very intricate solving type problem. So we're talking about solving equations. Okay. Now, eventually we want to work up to solving really intricate problems. This I would say is like a medium weight looking type problem that you don't even really need to know how to solve yet, but something like 3 parentheses x minus 1 equals 2x plus 7 could be a problem that we're going to know how to solve eventually. Okay. I can tell that it is an equation because there is an equal sign. I can also tell that I want to solve it because we have x's. So this right here is like my variable term because there's a variable on it. I have another one of those right here that I don't quite have yet because I haven't distributed. So we also have like a distributive property thing going on over here, which we should feel kind of comfortable doing, okay? On this side, we also have this 7. That is our constant term, which we kind of talked about all these words before. But you'll notice like that I said really quickly on this side over here. So for me, I always like to talk about drawing a line where my equal sign is. And then we have on this side, the left-hand side of your equation. And then over here, we have the right-hand side of your equation. And each of those things individually on their own is an expression. And when I'm talking about expressions, we'd like to simplify those things. This side, the right side, is a simplified expression already because I cannot make it any smaller than that. I can't combine those, they're not like terms. The left-hand side, however, is not totally simplified yet because I can distribute. So we talk about simplified or unsimplified when we talk about expressions, but when we're talking about solving, we're talking about something else, okay? A couple of things to keep in mind when we're solving. One of the things I like to say a lot is whatever we do on one side, we must do on the other. So whatever we do on one side, meaning if I do something on the left side, I must also do it on the right side. It's kind of a major rule because it's all about balance. You need to think of this as like a scale. And if I put 5 pounds on one side of my scale, then I need to put 5 pounds on the other to keep everything balanced out. So generally, when we are asked to solve what we're doing, and we're going to go through this step by step, so don't freak out if you're like, this is a lot. So to solve, we follow reverse order of operations. So the order of operations is that PEMDAS or GEMDAS, like please excuse my dear Aunt Sally, PEMDAS. The reverse of that is SADMEP, SADMEP. Meaning that like I'm looking for addition, subtraction first now, and then I'm looking for multiplication, division, then I'm looking for exponents, then I'm looking for parentheses, and this is kind of what makes solving tricky. You have to think reverse order of operations, and at the same time, we have to use the inverse property. To keep everything balanced. Meaning, if I have subtraction, the inverse of that is addition. Those are inverses of each other because they undo each other. They are opposites of each other. If I have plus 5 and I add a negative 5, I have 0. It's gone. Okay? So maybe we're going to make a note of that. If I have addition, the inverse of that is subtraction. And if I have subtraction, the inverse of that is addition. So they go both ways. One undoes the other. And we want to think about that first because that's first in my reverse order of operations. Next, if I had division, the inverse of that is multiplication. And if I have multiplication, the inverse of that is division. So they just undo each other. Then we have exponents. and this is getting into something that we won't really talk about until later, but the opposite of some exponents are roots, like a square root, and the opposite of a root is an exponent, like maybe x squared. And then the last thing in our reverse order of operations are parentheses. And sometimes you'll see them, but sometimes they're low-key parentheses. So we want to keep in mind low-key parentheses, and that happens last. And inside your low-key parentheses, or non-low-key, like actual parentheses, there could be addition, subtraction again, division, or multiplication again, but we just save all that stuff for later. So this is the whole process, but we are going to do baby steps. So if we turn the page, for today, we're just going to deal with solving one-step equations. Meaning I do one thing and I've solved for x, okay? So again, when we are talking about solving, what I like to say sometimes is, how do I get x alone? To see what it equals. So if we take a look here, I have my left side, right side, because there's my equal sign. My variable term is right here, and right now 8 is being added to it. So to get it alone, I need for that positive 8 to not be there. So I do the inverse operation or opposite operation of add 8, which would be subtract 8. So if we open that up, we have this right here. We have our sides. Because I want to get x alone and I have plus 8, I need to subtract 8. If I do it on one side, I need to keep everything balanced and do it on the other side of my equal sign. Then I write down what I have now. So x plus 8 minus 8 is just x plus 0. And I don't really need the 0. Like 8 and negative 8 is 0. So all I have left over here is x plus 0. On the other side, negative 6 minus 8 more is negative 14. And then if I look at x, it's alone. So I have my answer. Now you can always check your work by plugging it back in. So if I go to my original equation, x plus 8 equals negative 6, now I know that I think x is negative 14. So in place of x, I put negative 14 plus 8. And now it's a question. Does that equal negative 6? So on the left-hand side, I can simplify because negative 14 and 8, I can do that. And that's negative 6, which does equal negative 6. So yes, it is the solution. And I know I'm right, so that's good. Alrighty, looking at this one right underneath it, we have my variable on the left-hand side of my equation. And what is happening to my variable is 10 is being subtracted from it. So p minus 10. So to get that variable all alone, I need to do the opposite of minus 10, which would be add 10 on both sides. So if we open that up and try it out, we draw in our sides. Again, because I have p minus 10, I'm going to add 10 here. But whatever I do on one side, I must do on the other to keep everything balanced. It's like I've added a 10-pound weight here. I need to also add that 10-pound weight on the other side. And now when I simplify p minus 10 plus 10, well, I can combine these like terms. A negative 10 and a positive 10 is 0. And 0 plus p is just p. I bring down my equal sign. Over here I can simplify as well. 10 plus 6.4 is 16.4. And p is alone. So I have my answer, I think. But I can always check. And the way that I check my answers, I go back to the original equation, p minus 10 equals 6.4, but now I think that p is 16.4. So if I plug that in for p, and then subtract 10. It's like a question now. Does that equal 6.4? And 16.4 minus 10, I can simplify that, and it is 6.4. So I know that I'm right. Okay. Moving on, over here we have 7m equals negative 49. This is some low-key multiplication right here, because if I have a number smashed up against a letter, that is low-key multiplication. So if I have a number being multiplied by something, and I'd like for that number to not be multiplied by that thing, the opposite or the inverse operation is division. So I must divide 7 on both sides. So here are my sides. Boop, boop. Okay, so if we open that up and try it out, I'm going to draw my sides. Again, because I have 7 times m, I'm going to divide 7 on this side and that side. And I always like to do my division as a fraction bar. You could put the little line with the dots, but I prefer a fraction. And 7 divided by 7 is 1. And so I have just 1 m left. And I don't really need to put the 1 in front of the m, but you can. And then on this side, I can simplify. Negative 49 divided by 7 is negative 7. And then m is alone. So I think I have my answer. And I can always check by going back to the original equation, which was 7m equals negative 49, and plugging in what I think m is. So I think that m is negative 7, so I plug that girl in. And now it's a question. If I multiply this out over here, will it equal negative 49? And it sure does. So I know I'm right. Okay. We have, last but not least here, actually I might do one more after this. C divided by 4. Fraction bar is divided by equals negative 1.3. So C, my variable, is on the left-hand side. It is being divided by a number, and I don't want that number to be divided anymore. I want C all by itself. So to undo the divide by 4, I have to do the opposite of divide, which is multiply by 4 on both sides. Okay, so we open this up, try it out, we draw on our sides. Again, because I have C divided by 4, I want to times by 4. And guys, real nitpicky thing here. I'm not timesing 4 in the denominator. I'm timesing the 4 to the numerator. So really this is 4 over 1. And that's because 4 divided by 4 is 1. And then I have 1C, which is what I want. Now, I multiply by 4 on the left-hand side, so I have to multiply by 4 on the right-hand side. And 4 times negative 1.3 is negative 5.2. My God, I did that in my head. I really hope it's right because Dustin will speak me out. And I can always check to see if I'm right. Oh, I think I'm right because C is alone. So check by plugging it back in. So in place of C in my original equation, I'm going to put negative 5.2 over 4. And I wonder, does that equal negative 1.3? And like 4 goes into 5 once with 1 left over, and 4 goes into 12 3 times. Oh my goodness, I'm so good at dividing, and it's negative because there's 1 negative. So yeah, they do equal each other, yes. Now, last but not least, I know we put a whole nother page in here, but I think I want to save that. I do want to talk about a fraction. So when I have, this is like one other way to solve, kind of up here. When I have a fraction, like 2/3, smashed up against a variable, and then that's equal to 8, truly that fraction is being multiplied, so you'd want to divide by the fraction, but we don't divide fractions. What we do in this case instead is we multiply by the reciprocal. And reciprocal is just a fancy way to say the flip of it. So flipped fraction. So what I would do on both sides of this equation is multiply by the reciprocal, so the flip of 2/3 would be 3/2. If I do it on one side, I have to do it on the other. And that works out super nice over here because what I am going to end up having is 6/6, which is 1x, and so x is alone. On this side, I might draw my bar and put a 1 under the 8 because you can always put a 1 under, and then do some cross division. Like 2 can go into 8 4 times, and then 4 times 3 is 12. And then we could check our answer because x is alone, so I think I'm done. So I think we're going to save all of page 15, either for class tomorrow or for another video notes session, because I feel like this video is very long. So hopefully that was okay and not too tricky.